practicing with our Trig Identities Day 3. So at this point, you should have some experience and kind of know what's going on a little bit here. We're going to establish the identity. Let's pick a side. Which side do we pick? The more complicated side. So we're going to do left-hand side. Hopefully by now you realize that. Okay, what are we going to do to this left-hand side? When I see a bunch of fractions, and we have to make something that's not a fraction, I'm thinking we have to add fractions. So we're going to need some common denominators. Okay, so let's leave a little bit of space next to this fraction. In fact, let's get it all set up here maybe. We're going to multiply that fraction by something. And the second fraction, well, he's going to need to get multiplied by something as well. Okay, so you want to make common denominators. Well, this denominator has a sign, so let's give this first fraction sine of theta over sine of theta. And this fraction is going to need that quantity 1 plus cosine theta. So some of the things I see sometimes are people putting things there and they go, oh, let's cancel it. Well, of course, you just put it there because you're trying to make something. So if you write something down, don't initially think to cancel it away. You put it there for a reason. So these fractions have the common denominator, 1 plus cosine of theta times the sine of theta. Should I multiply that out? Let's not do that until you see a need for it. Okay, let's not do that. Should I multiply sine times sine and make sine squared? I'm thinking that would be a good idea, sine squared. How about here? Do you think I should distribute those two things together? If I do that, I'm going to make blah, 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 cosine squared. Do you really want to put a sine squared and a cosine squared together? Yeah, of course we do. Okay, this is a plus, so we don't have to worry about distributing a negative. So when we multiply this out, it's 1 plus outers and inners, that's 2 cosine of theta plus cosine squared of theta. Okay, now what I was telling you about were these sine squareds and these cosine squared. So let's take both of those terms out and instead let's replace it with, I'll use an orange pen, a 1. Okay, both of those orange terms there are a 1. Okay, some people are starting to see the end in sight right now. Okay, sine of theta. Let's go take a peek at the answer. Our answer needs to have a 2 and a cosecant. Okay, I'm starting to see it. Let's add 1 plus 1 and make it 2. Should we add that 2 as well? Well, no, because that one has a term on it. Okay, so those are not like terms. We'll have to keep it separate. 2 plus 2 times cosine of theta. 1 plus cosine of theta times by a sine of theta. I'm going to put parentheses around this numerator just in case there was anyone thinking they're going to slice something off of that. Okay, I'm going to go over here. Any ideas? Maybe we can do some factoring in the numerator. The only thing I see that they both have is a 2. Let's factor out a 2. Well, that's not bad. I do want a 2 eventually. Okay, I like that. That leaves us with 1 plus cosine of theta. Is anyone getting excited now? We're near the end for sure. 1 plus cosine of theta times a sine of theta. Okay, we're going to cancel that quantity and that quantity. That gives us 2. And then I'm going to write sine of theta is 1 over sine of theta right here, just so that I could see him clearly in the denominator. And 1 over sine can be written as cosecant of theta. I don't know if I've mentioned this to you guys in class yet, but what you can't do is start blah, 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 get a bunch of junk, and then magically get the answer. Okay, you cannot be a faker. You're actually going to have to show line by line how something is happening. So don't do too many steps at once so that someone reading it can follow. Okay, number 2. Number 2. Make sure you guys are using pencil for your notes and stuff. Okay, let's just grab the left-hand side. Why not? Left-hand side, doesn't really matter which side you grab. Any ideas on how they think we should proceed with this problem? Did I hear somebody say conjugates? Okay, should we do conjugate of the numerator or the denominator? I don't think it really matters. I'll multiply top and bottom. It's got to be the same. What you do to the top, the bottom. I'll do 1 plus sine of theta for both of them. Okay, so I'm noticing that the numerator here is 1 plus sine of theta. That's quantity squared. Okay, and the bottom, conjugates. That's 1 minus sine squared of theta, which we can replace. That's a Pythagorean identity. So let's go ahead and write that as cosine squared. Okay. Maybe it's time to distribute that numerator out. What do you think? Multiply that one out. Okay, don't forget outers and inners. We've got to make a middle term here. That's going to be 2 sine of theta plus sine squared of theta. And since there's a denominator of cosine, I can give each and every one of them a cosine squared. I can give each and every one of them cosine squared. Okay, how are we looking? Let's go take a peek at our answer here. Oh my. Well, I do not see that happening at all. Did we do something wrong? We've got conjugates, difference of squares, the identity, is that right? Okay, I do not see cosecant. Oh my goodness. Okay. I think this is a great example. I'm going to start this problem again. Let's abort. I know it happens sometimes. This is how it works, so don't get frustrated. Just get a different color pen out. Let's take that left-hand side again. And this time, I'm going to do a little bit more thinking. Okay? This is to show you how sometimes you have to know when to quit and try again. I want to make a fraction. Well, I have a fraction, so that's good. I have a fraction. I want the numerator to have a plus sign. Well, it does have a plus sign. That's nice. And I want my denominator to have a minus sign. Well, the setup of this is actually looking really, really nice. Okay, well, let's see. Is there any way for me to turn a 1 into my cosecant? Is there any way to turn a sine into a 1? What if I were to divide? If I divide all the terms on top, well, then I would have to divide all the terms on the bottom, because what I do to the numerator, I need to do down there. So if I were to divide them all by the same thing, what would I divide by to make a 1? What if I divide by sine theta there and there? This is legal. I'm going to divide everybody by a sine. All right, let's see what happens there. 1 over sine of theta is cosecant of theta plus sine. That turns out to a 1. Cancel, cancel. Here's another cosecant of theta. Hey, we did it! And it only took 1 step. Sometimes you have to quit when you realize instead of simplifying, you're actually complicating. All right, don't forget that trick. It happens a lot. All right, what else do we have? Here is a great example. It's kind of messy. I see cosines and I see sine squareds. You can't exactly put cosines that aren't squared with sines that are squared. So let's take somebody out of here. I want to remove something, obviously. Let's get it to match. So let's get sine squared. In fact, maybe what I'll do, let's write down the identity. This helps. sine squared plus cosine squared equals 1. Well, here's a 1. What if I move the sine squared over there and say 1 minus sine squared? That would equal cosine squared. Well, let's do that. Let's take out 1 minus sine squared, and let's replace that with cosine squared of theta plus cosine of theta. Can you add those together? No. You could factor a cosine out. So some people debate. If you factor out a cosine and get cosine of theta plus 1, they say, oh, I like that because it's multiply. And some people say, well, I like this because it's smaller, because it's 2 terms. I guess you could argue all day long. Those are both good in my boat. I'll take either answer. But having all the same kind of identity is better than having it mixed up. Okay. Which side should we pick for this one? The more complicated side. I'm thinking the right-hand side, because I know how to make common denominators. I know how to put those together. I'm not sure how to break something up. Oh yeah, I know how to do that. It's called partial fraction decomposition, and it takes a lot of steps. So let's pick right-hand side. Good choice. 1 over secant of theta minus 1. Maybe we should leave a lot of space, huh? Maybe get it set up a little bit. Okay, plus 1 over secant of theta plus 1. Let's put some parentheses, get it all set up here. We want to make a common denominator. So what does this fraction here, the first one, need, top and bottom, to match? He needs a secant of theta plus 1. Secant of theta plus 1. And this fraction needs secant of theta minus 1. Okay. Now, since it's just a 1, there's really no arguing as to whether we should multiply the numerator out. The numerator is secant of theta plus 1. Since the denominators are common, I'm just going to put one fraction bar right away. Over here we have plus secant of theta minus 1. Okay, should we distribute the denominator since they're conjugates? Yes, I think we should. Secant squared of theta minus 1. In fact, whenever you have conjugates, go ahead and multiply them because it makes a difference of squares, which are awesome because those are the identities. Okay, we got a couple more steps here, and I'm thinking some of you might actually be ahead of me at this point, right? Plus 1 minus 1, a secant plus a secant is 2 secant of theta. Sometimes I like to take a break and see. Was I supposed to have? Oh, yep. Getting a 2 is a good idea. And how about that identity? Did you figure that out yet? Secant squared minus 1 makes tangent squared of theta. Okay, let's go ahead and take a look at this here, because this is what we're trying to make. We're trying to make a 2, which I have. We're trying to make a cotangent, and we're trying to make a cosecant. Okay, maybe we should work with these fractions here a little bit. I'm going to write 2 times secant of theta times 1 over tangent squared of theta. Now, not everybody needs to do as many steps as I'm going to show. Some of you can do a lot less than this because you can kind of see what's going on. I just want to make sure that this video is clear. Okay, so this is 2. This is secant of theta. And 1 over tangent squared, that's a reciprocal identity. That's cotangent squared. Okay, so we're getting close. Let me just use an underline here. I need a 2, and I have a 2. I need a cotangent. Well, look at that. I got 2 of them, so I need just 1 of them. So let's go ahead and separate this up a little bit more now. Maybe I'll take one of those cotangents that I needed and write it first, cotangent of theta. These are the things that I need, and I'm not going to mess them up. So what else do we have? We have secant, which is 1 over cosine. And we have another cotangent, which is cosine over sine. Okay, and I need yet to have a cosecant. So out of all this stuff here, we need to make a cosecant. Do you see how it's going to happen? This cosine can cancel with that cosine, and we have 1 over sine, which is indeed the cosecant. Cosecant of theta. We did it. Okay, you don't need to do that many steps. I just wanted to make sure that it was clear for everyone how we were making all that stuff. All right, do we have any more here? Ooh, number 5 looks fun. Why don't you guys pause this video and give it a try. Let's all do the same side. Let's all work on the left-hand side. That way when you unpause it, which you're going to do, we'll all have the same work. Okay, go ahead and pause it. Okay, did you already pause it and try some stuff? I don't think conjugates are the best way. Pause it again, try some more stuff. Did you guys get this one? If you look at this problem, it looks almost like that answer. I need a plus sign on top, and we have one. I want a minus sign, and we do. So I don't want to mess it up too much, but I want this cosine to turn into a 1. Did you guys remember that trick where you divide everything by the same thing? Let's divide them all by cosine. Divide by cosine. Cosine of theta, cosine of theta. And so the first term in the numerator becomes a 1. And 1 plus cosine is secant. And 1 minus secant of theta. How many people got this one? Hopefully the next time you see it, if it's on a test or quiz, you'll be able to get it. Okay, I think I've given you lots of pointers. And you're looking really good. This does not have a left-hand side, right-hand side. It just has one side. And it's fractions. There's 2 fractions. So what you're going to need to do here is make common denominators. Cosine of x, 1 minus sine of x. Let's go ahead and get it all ready for you here. We're going to go like this, go like this, go like this. Sine of x over cosine of x. He's going to need some stuff too. Let's make some common denominators. Okay. And this is the part of the video where we say goodbye and the video is going to end. But don't you dare stop this problem. I want to see the end in class tomorrow. All right, let's see who can get it.